So let us discuss few questions based on units and dimensions from this chapter of units and dimensions, specifically based on dimensions. See here. Yeah, I hope the page is clear for you. Yes, guys, I hope the screen is visible for you. I think it is clearly visible to you. Right. Just I will mention a few questions here. M power 1, L power minus 1, M power 1, L power minus 1, T power minus 2. And fourth option is M power 1, L power 1, T power minus 2. Right. So this is, you can note down here also, it is NEET 2020. It is asked in NEET 2020. Okay, so simply you can remember the simple two steps whenever you are cross-check the dimensions. So you have to remember the formula of the quantity which you have asked. See here, we know that stress is equal to, force by area, force per unit area, force by area. So force. So this is the first step. You have to write the formula. You should be able to recollect the formula. Then try to write as a second step. Try to write the units of that quantity in fundamental units form. For that purpose, write the formula for force. Force is nothing but m into a by area. You can take capital A. Now the stress units can be expressed as unit of mass, as force is mass into acceleration. Unit of mass is kg, acceleration is meter per second square by area. Area unit should be meter square. So if you simplify this, meter gets cancels, then you can write it as kg per meter per second square. So in terms of MLT, then finally you can write the dimensions. Therefore the dimensional equation for stress in terms of MLT can be expressed as kg is unit of mass, so m power 1 per meter, meter power minus 1, meter is unit of length, so L power minus 1 per second square, second is unit of time, so T power minus 2. That's it. This should be the dimensional formula of stress. So this is how you have to write the dimensional formula of any quantity in a simplest form. Okay, next let us see one more question from previous years. See here, the question is, this is asked in NEET 2021. We'll work out JEE based questions also afterwards. Next question is, so it is I can mark here NEET 2021 question. The question is using as fundamental physical quantities. Then find the dimensions of energy. Then find the dimensions of energy. Right. You can note down the options as well. You can write down the options. First option is given as FAT. The options are given like this in square brackets, FAT. Second option is FAT square, FAT square. Third option says FAT power minus 1, FAT power minus 1. Fourth option is FA power minus 1, FA power minus 1, T power 1, just T. These are the four options given. Then what is the correct option? So we are asked to find energy, dimensions of energy. So in these kind of cases, how to do? You have to remember the process, practice it. Okay, then similar kind of questions I've asked even in JEE as well, so you can understand easily. So how to do this kind of questions? First, you have to understand that Usually we know as per the SI system, the fundamental quantities will take fundamental quantities we consider are fundamental quantities as per SI system are 7 fundamental quantities are there: length, mass, time, current, temperature, amount of substance, luminous intensity. 7 quantities. But here, as per this question, force, acceleration, and time are chosen as fundamental physical quantities. These are fundamental quantities. Then, in terms of this, what are the dimensions of energy? So, what you have to understand here is you have to understand that energy as a function of these parameters. You have to write a relation. Let us say energy E, energy represented as E, is a function of these three quantities: force, acceleration, and time. But with what powers we don't know. Let us say it is F, okay, power A, and acceleration A, power some. Let us take some power B, and T power some term C. Let us take. Then we can consider here as force. Force is actually, the dimensions of energy. Energy is nothing but work done. Work done is force into displacement. And by writing the reduced forms, we can directly write the dimensions of energy. Are you right here? Energy is nothing but work done. For your understanding, I am writing clearly. Is nothing but force into displacement. So to write the dimensions, I'm giving reduced forms. Force is mass times acceleration into displacement. So the dimensions can be expressed in terms of mLT as mass, kg. So m power 1. Acceleration is meter per second square. This is distance, also meter. So meter square means L power 2. Per second square means T power minus 2 is the dimension. So dimensional formula of E. Okay. And force, here only have written m into E. M into E is kg, so into meter per second square. So m power 1, L power 1, T power minus 1. So this way you have to substitute. Let us take E as m power 1, L power 2, T power minus 2. And F, force, because F is equal to m into A, we have to take this as, this is dimensional formula as m power 1, ml power 1, t power minus 2. Mass into acceleration. Mass, m power 1, acceleration is as its unit is meter per second square. Meter means L power 1, per second square means t power minus 2 whole power. If you say this equation 1, if you follow, you'll understand this. Okay, whole power A into A, acceleration. Acceleration is meter per second square. Meter per second square. Here in the side you can write acceleration. Unit you write meter per second square. Then dimensions of quantities you can take. Meter, unit of length. So L power 1, say, per second square. Unit of time, T power minus 2. So A power B. So this entire thing power B into T power C. T is time only. So you can write as it is T power C. Now on simplifying these, we get so you can write this as m power. If you just multiply with these powers, you can you'll get m power e, L power e, T power minus 2a, like that. And if you simplify, if separate out mlt terms, you can write m power a, here L power a, here L power b, here no L, so L power a plus b you will get, and T power minus 2a, T power minus 2a in the first term, minus 2b in the second term, and plus c in the third term. Okay, if you compare this with the left side part, that is m power 1, L power 2, T power minus 2, then you can understand that m power a is equal to m power 1. On comparison, a will be the powers. If you equate a is equivalent to 1. So on comparing, we can write on comparing. This kind of questions we have to practice, guys, otherwise you won't understand. Okay, on comparing powers on both sides, powers on both sides, we can say a is equal to 1. A is equal to 1. Yes, one term we got. Then a plus b is equal to 2. A plus b is equal to 2. This implies b is equal to 2 minus a, but a is 1, so b, 2 minus 1 is 1. So b is also equal to 1. A equal to 1, b equal to 1. Then what is c? So to get that, you have to what do you call? Yes, simplify the, consider the powers of uh, yeah t. So minus 2a minus 2b plus c should be equal to minus 2. But a is 1, b is 1. So c can be expressed as c is equal to minus 2 plus 2a plus 2b is equal to minus 2. A is 1, b is 1. So plus 2 plus 2. So what will you get? 2. So c is 2. C is 2. So now if you substitute this in equation 1, then you will get the dimensions of energy. So in terms of A, B and force, acceleration and time. So from equation 1, therefore equation 1 implies dimensions of energy is equal to F power A is 1. Yes, F power A power B is also 1, A power 1, and T power C is 2, so T power 2. This will be the correct answer, and in which option it is there, that option you can choose. So I think it is option B. It is option B, F E T power 2. So this is how you have to do this kind of questions. Yes. So and the two times a question is asked, say this is this kind of question again, like earlier, before in 2014 also asked. 2014 also a question is asked, similar kind of question. I give you the question here, you copy it and try yourself. 2014 similar kind of question is asked. 2014, the question is, if force F, velocity v and time t are taken as fundamental units, quantities are taken as fundamental quantities, then the dimensions of mass, are options. First option is given as FVT power minus 1, FVT power minus 1. Second option is given as FVT power minus 2. Right. Third option is FV power minus 1, T power minus 1. Fourth option is F V power minus 1, T power 1. So these are the options given. So how to do it? Same procedure you have to use. You're asked to find what? Dimensions of mass. So as we know that force is equal to mass times acceleration. And as acceleration is velocity by time, we can also write this as mass into velocity by time. We can take it as t. So by using this, you have to write the expression for mass. M, this implies M is equal to F T by V So if you want dimensions of mass, this implies from this you can say dimension from this the dimensions of mass is equal to dimensions of force to dimensions of time by dimensions of V. But as per the question here, F itself is taken as fundamental quantity, T is taken as fundamental quantity, V is also taken as fundamental quantity. So therefore, dimensions of mass is equal to F V. If we take two numerator, then it becomes V power minus 1 T power 1. So F power 1 V power minus 1 T power 1. So this is the correct answer. F power 1 V power minus 1 T power 1, which is that option D. Option D. Right. Yes, guys. That's it. So this kind of questions practice once. With this, just I'm winding up now.